Mike did a good job. IoT is a big topic. Infrastructures to support it are going to be complicated and complex. They're going to be delivered in services. And there's going to be lots of situations where people are looking for, how do I create a service where I can reuse a sensor, or how can I reuse an aggregator for a different sort of deployment methodology in the same factory? All of these things we're all working on together. I think you saw how Docker and Microsoft were integrated on their IoT platform, but we've also, in the last 2 years, been highly integrated in application or server-side development, as well as just propelling content from server side or from device side, if we're thinking of this in an IoT perspective, and aggregating data toward where maybe the cloud analytics are going to be doing the algorithmic workloads against the compilation of that data, right? So Docker has been integral in Microsoft, and we're humbled by our relationship and partnership with you all, because it's really an advancement in how you can create portable, differentiating application workloads and deploy them across many different infrastructures, right? Maybe at the end of it, landing on something like the Azure IoT or the Azure platform to be doing the compute cycles against the data that you're pulling together. So, again, it's a complicated topic. And again, my name's Cyrus. I have the honor of being able to build out the public sector practice here for Docker. I've been here the longest of anybody, and for better or worse, been involved in all of our government-based distributions and interactions across the board, whether it's from the civilian all the way up to our efforts within the IC. So we're very happy to be here and be working with Microsoft specifically across the board in the solution sets that are out there. Real quickly, I want to get to Andrew, because Andrew's got some really great stuff. Using the Azure IoT platform to show you some really interesting things and how we're working across multiple devices and infrastructures. But just a simple thing on Docker and why that's important. That's pretty basic stuff. Docker, if you don't know, we are the stewards, as a company, the stewards of the open source Docker projects that are available today through the Moby project. We'll probably show you a little bit more about that today. But we're also the first company to create something called a containers as a service model to deploy enterprise distribution and containerized management across infrastructures. Again, how that might apply to IoT systems is pretty relevant, because in an IoT framework, you're dealing with everything from a device that looks like this or smaller, right, to the large servers that the data finally aggregates to where you can make actionable and mission sort of decisions upon that aggregated data. The success that we've seen, I think, in the last 12 to 24 months, I would say is pretty phenomenal. One of the big reasons is because of our relationship with Microsoft. Everybody's known the container technologies in the world of Linux and Linux infrastructures. But what's new with us is also the ability now to work on Windows servers platforms and Windows applications, which are tightly integrated, and it's not just a sort of a sales partnership, but it's a tight integrated partnership on the engineering side as well. The creation of the capability to run, for Windows Server to actually run containerized workloads is transforming the way we view infrastructure. Again, to your point, to create an application that can run as a Windows container on Windows Server that can also be ported to environments within Azure very seamlessly, right? In the same capacity, I can take a containerized deployment or creation on the Linux side of the house and deploy that to something like an Azure service and be able to consume that hybrid sort of architecture. And that's where we've really partnered with Microsoft and the Microsoft engineering team to do some really interesting work. To give you an idea, I like to use this in the way of a calendar. From about January of last year, we were around 2 billion pulls from Docker Hub, to show you the sort of the advancement of our relationships, I think, in our announcements with Microsoft last year, as well as other major corporations on the hardware side and on the chipset side. Oh, I'm sorry, I'm stepping away. I'm sorry. Should I lean down? But we've went from about 2 billion pulls. So a pull is somebody interacting with a containerized content on our hub. So I reach up, I need a Redis, I need a Node.js, I need something to build my application with in a containerized format. And we've advanced from about 2 billion pulls to over 14 billion within about 12 to 14 months. That's an amazing advancement sort of in the way of technology adoption. And a lot of that is on platforms like Azure, what's going to be offered on the Windows Server 2016 platform, as well as across our Linux infrastructures today. These are some of the efficiencies we gain, and I think it's important to know the fundamentals of these efficiencies and the way that we can consolidate virtualized environments on the infrastructure side, but also we really propel the adoption of cloud. right? The fact that a containerized workflow is immediately portable once it's in a Docker container, once it's in that format, gives you immediate access to cloud utility-based economic models as well as infrastructure architectures that you just haven't been able to get to in a traditional sense before. It's an accelerator technology that we've seen really take, as you saw, sort of a mass adoption curve just over the last 2 years. To give you an idea of where we've grown as a company and how we've partnered with companies like Microsoft is simple. We started off as a developer community. Docker actually started as a tool that our CTO and founder, Salman Hikes, created to promote adoption of his own cloud service called .cloud, right? He didn't realize what he created was more important, right, than his actual cloud service, which was his company. And as soon as he recognized that, it transformed his direction, and he stopped being a cloud provider and started to create this innovative technology to create portable and infrastructure-independent application workloads. From there, we've seen the developer community really adopt it as a fast way to deploy applications, and that has transported into an ops problem, right? This is what we've dealt with over the last 1.5 or 2 years. Is here's an operations group all of a sudden getting hit with all these containerized workflows. What do I do with this? How do I secure it? How do I create an enterprise-grade distribution of it? That's where we've shifted in the last 2 years around our products and our partnerships is into the enterprise, but more so in the partner community. So as much as a government customer is our customer, Microsoft is our customer. What we are is becoming the package of software deployment or the next generation of the way software will be deployed regardless of infrastructure, whether it's a sensor or whether it's a deca-core box, right? It's the way applications will be deployed. I feel personally, in the future development efforts to come, right? It's an advancement in the way that we deploy. People are going to go away from installing software to just running it. And so our ecosystem is as valuable to us as anything, and that is providing a platform, a stable platform, and a deployment capability, whether it's Microsoft applications or various other enterprise corporations that we work with to deploy their ERP infrastructures or their infrastructure components in a consumable container format. Real quickly, this is the way that our world looks today. I think you saw some of the way that you architected the different Linux distributions in IoT and the way that the open source Azure container service also works. It's similar to us. So if you're familiar with open source projects and open source project development curves, Moby is our pure open source project. Right? It includes every basic constituent of what Docker is in its own project, and we are innovating per project in the Moby project today. We have Community Edition, which is a freely available version for developers. And then we have our Enterprise Editions, where we're really partnering with, on the production side, with Microsoft and a lot of these IoT environments to deploy production-grade, production-consistent, and the cadence of a production-delivered software model. So why does Docker matter to IoT, or in general, why has it been such an sort of, I would say, a propelling agent for cloud adoption or a further commoditization of infrastructure as a service? And it's this in the most simple way to put it. If you're familiar with VMs, right, and the dependency models of VMs specific to an operating system to run an application, then what we have done is basically, as a container hypervisor, we have made it possible to break the dependencies of applications on a complete stack, to containerize the dependencies of specific applications, and to share a single operating system host. Right? We don't care about what color that host is, right? But to share the actual underlying components and kernel capabilities of the underlying host across a broad amount of services running on a single operating system or running on a single VM. So one of the things that this creates really importance to, it's not necessarily VMs versus containers, but a lot of the value that we've seen is VMs with containers. And why this is an important map to see regarding IoT and why it's specific to IoT is regardless of whether these applications are traditional styles apps where you're shipping 3 gigs worth of a dependent OS, or whether, like in our partnership with Microsoft and others, we're creating Linux kit and minimal OS images for devices like sensors, for devices like aggregators in the field, these ARM devices, these UAV drones, these types of environments where you have to have a smaller package of deployment, all of those types of things can be deployed as a Docker container. The infrastructure is irrelevant, right? The fact that you can deploy a common framework, a common unit on which all of your applications and your application dependency reside really transforms the way that you can deal with infrastructure, whether that's an edge device, whether that's an aggregator, whether that's sort of then it goes to the algorithmic workloads, right? And the analyzers to the mission decision making of the data center deployments of all the data, right? It doesn't matter where that container hits, because as long as Docker's there, it will run as it was created to run. And I think that's where it really becomes important in our partnerships, as much of the different services within the Azure IoT framework is delivered as containers. Right? It's just the transformation of the way software is going to be delivered. And the modernization efforts that we're making in partnership with Microsoft, as well as Accenture, to modernize traditional applications into not only just modern infrastructure, right, but to also modern microservice architectures that couldn't have gotten there naturally without the advent of something like containers, right? And we're just happy to be a part of that partnership. And so that's a high level of where IoT is, why it's so important to us. We feel like this is one of the most fastest advancing segments of our business right now. IoT is consuming a lot of not only the cloud providers' attention, but also the hardware providers' attention and the chipset providers' attentions. And we're right in the middle of it, trying to make sure that we can be the most efficient packaging agent for software delivery, whether it's a sensor, whether it's a big server at the end of an IoT work chain, right, or an architecture development workflow. So we're going to shift and do some fun stuff. Welcome Andrew Weiss. Everybody's here.
What's boosting my ego here?
We're very happy to have Andrew.
Thanks, Chris. So as Chris said, I'm Andrew Weiss. I lead our federal solutions engineering efforts here in the DC area, working with agencies from civilian to DoD to IC on some of these same scenarios that you'll see today. And there's some really good content out there just kind of in the ecosystem. There's a really good book that I've been taking a look at that I highly recommend. It's actually called IoT Inc., How Your Company Can Use the Internet of Things to Win in the Outcome Economy by Bruce Sinclair, and we'll send this out after. It does a really good job giving, what IoT is at a high level. It talks about the business objectives for IoT, and most importantly, it talks about how your organization, regardless of whether or not you're using IoT today, can start getting into the world of IoT. So for things like Gov to Citizen services, Citizen to Gov, and so forth. But what we're going to do today is this demo is going to be one of the more involved demos that I've actually given, so knock on wood, everything kind of goes smoothly. But we're going to show the power, we're going to kind of connect these two concepts. We've talked about Azure IoT in general, we've talked about containers, but how can we use containers to actually deploy our software to these devices in a secure fashion? As we all know, security is a big topic within IoT today, especially amongst government entities, and we want to show you how you can use containers to actually deliver software in a secure manner. The scenario we're also going to use, we're going to pretend we're a fictitious systems integrator that's building embedded systems for a DoD entity. In this case, it's going to be a little mini robot that you'll see here shortly, but all the concepts that I talk about and that you see here today can be applied whether or not it's a little device that sits on the table here, or whether or not it's an actual submarine or an airplane or drone and so forth. The concepts still apply. But I just want to rehash that IoT for most folks has really been a non-starter up until recently. With the advent of cloud computing services and services like Azure IT Hub and so forth, IoT was difficult. You had to stand up significant infrastructure in your data centers, and obviously you had a lot of other tasks that were kind of taking priority over IoT. Many agencies have been wanting to do IoT for a long time. Some agencies have been progressing at that a little bit faster than others, but really the cloud has really catapulted this momentum amongst IoT. Really having to manage thousands of devices or millions of devices in the field was cumbersome, and at the end of the day, the innovation on these devices was constrained. So cloud and containers are making IoT easier than ever before. We heard from IoT services that are being provided that you'll see here shortly. And also being able to provide development portability across all those workloads is being done so with Docker and containers in general. Not only can Docker be used for traditional development work streams, which is what has made it so popular today, but we can use it for the devices that are as small as 100K RAM, all the way up towards traditional server-side application development. The beauty of containers is that you can also run it on all kinds of different architectures. So you can, of course, run it on x86, which is the prominent use case today. But we've also been seeing more and more use cases in the ARM world, and even embedded systems as well. So if you look at RTOS, real-time OS, and so forth, and I'll talk a little bit more about that. I'll pause there. How many folks know what an embedded system is? I'm about to. So for folks that don't know what an embedded system is, how many folks have used their washer or dryer recently? Or been on an airplane? Or how many folks have smartwatches? Embedded systems are literally everywhere, in the airbags in your car, in the electronics in your television set, in the cameras that are in the room today. These chips have been around for a long, long time, but historically they've been very difficult to actually develop for. You need to have a specialized skill set, or you need to spend millions and millions of dollars, like F-35 program, or other large, expensive contracts to actually develop for these systems at scale. But containers are changing the way and making the development of embedded devices a lot easier and expanding it to the masses. And what we're starting to see is that agencies are looking to actually combine existing development streams with traditional workloads alongside embedded systems development through contractors and so forth under the same purview with containers and so forth. And you'll see that here shortly. So what you'll see is containers allowing you to wrap source code for an embedded device, and also containers running on larger devices, but also in that IoT realm. And I mentioned this before around security. Chris mentioned this a little bit, but security is a really big focal point amongst IoT. On the work that's being had right now with things like minimal footprint OSs and being able to really shrink the size of the operating system supporting your containerization platform on embedded devices is also really critical. So some additional government IoT use cases. Mostly what we're seeing in the early days with containers specifically is in the DoD and space agencies. Drones, submersibles, rovers, avionics, but this is starting to expand beyond just DoD and also in civilian entities as well. We see this with sensors and collecting data for agencies like NOAA, EPA, and so forth. And what's really interesting, and what Mike alluded to, is being able to run analytics closer to the devices themselves, and of course powered by containers. So if you look at what GSA did recently with the AI citizen or assistance pilot, and being able to take that analytics or take that data as it's coming in live on the edge devices and running processing on those, running them through neural networks, and again, doing all of that through container technologies, it presents a really interesting scenario. So everything you're going to see is going to run on Azure IoT Hub in Azure Government, which is relatively new to the Azure Government side. So we're going to use the twin device properties that Mike mentioned as well. We're going to tweak things up. We're not going to use the Azure IoT Edge service, but I will provide a little bit more context into this. This is a new service being developed by Microsoft. This is an evolution of the IoT Gateway service. The really cool thing about this, when it's updated later this year, is it's going to run entirely with Docker containers. So you'll be able to run the IoT Edge service and do much of what I'm going to show today with a little bit less overhead. And again, all with Docker on your edge devices themselves. So the demo. So again, this is one of the more involved in demos that I've done, but knock on wood, it goes pretty smoothly here. What we have here is we have an actual embedded device up on the stage. This is an Arduino-powered rover. This is actually a kit that you can buy. And again, if it's an embedded device like here, or if it's a drone, the same process is going to apply in your actual development stream. We also have an edge device, which I'll talk about shortly. But I'll reiterate with this slide that you can use containers for all tiers of development. Now, Docker, as it stands today, has to run on a slightly beefier tier in the edge world. So Docker is going to run, in this case, on our interactive tier. So this is a larger edge device. This is running an ARM chipset. Actually, in this case, it's going to run an x86 chip, but you can run Docker on an ARM device like a Raspberry Pi or similar. Now, the Arduino is actually a lower tier device. You cannot run Docker itself on this device because it requires a Linux kernel. And these devices are typically powered by what are called MCUs, or microcontroller units. In this case, this only has 128K of flash. The Docker package itself is a few megabytes, so that's not going to fly. But what we are going to do is we're going to wrap the source code, which is a variant of the C programming language. Actually, it's the Arduino variant. We're going to wrap that code in a container, and we're going to push it through the same exact continuous integration and continuous deployment process that we do just alongside all our other apps, our Java apps, our Node apps, our .NET apps, and so forth. And we're going to run that all on Azure Government, and we're going to deploy it through the Azure IoT Hub. So this just talks about that today. So let me go ahead and show you what the actual robot looks like. So bear with me here while I just transition. So I'm going to go ahead and just turn this on. So again, this is powered by a couple of batteries. So there are 2 motors on this device. So again, we're using a small device here, but imagine this in the realm of avionics, a drone, a submersible. The concepts are still applicable. So this is powered by 2 motors. This is a few AA batteries in here, which I'll turn on with the switch. And then also, there's a 9-volt battery powering the actual microcontroller unit itself. So this is a rover. It's not autonomous, so it's not that cool. So if you've been walking around DC, you've probably already seen some of the robotics that are driving around. We don't have that fancy of a device in here, but again, the concepts apply. So what I'm going to do is I'm just going to open up this application right here. I'm going to go ahead and connect to the device. So hopefully no one else is running the same application with these same Bluetooth characteristics. Otherwise, we have a problem. And we're just going to drive the device around the table. Pretty simple. Now, the problem with this device is my contractor, again, let's pretend we're in the DoD realm. And my contractor has said, all right, we need to update our devices in the field. They're moving too fast. This is way too fast for this small table. So what we're going to go ahead and do is we're actually going to make a source code change and update the code for this device. We're going to run it through our CI/CD pipeline, and we're going to actually do a firmware update on the device, all synchronized through Azure IoT Hub. Now, in reality, you would do somewhat of a firmware over-the-air update because you don't want to take thousands of devices because they could be buried underground. They could be out in the field and connect them back to a base station. But in this case, we are going to connect this device to a base station, or what we call our edge device. So I'm going to go ahead and just switch screens here. And I'm going to turn the batteries off. And we're going to connect this device to our edge. Let me go ahead and set this up. So I've got a little projector here so you can actually see what's on the table. Awesome. So what you're seeing here, this is our edge device. An edge device in the field, again, could be powered by Azure IoT Edge service. In this case, since that service is not available, we're just going to run a simple vanilla version of Ubuntu. It's actually a stripped-down version of Ubuntu running on this device. This is an x86 device, and this is going to be acting as our device update base station. Thanks, Tina. And what we've done is we've plugged in our little robot here into the device itself. And we're going to stage it for an update. So this whole update process is going to happen through Azure IoT running on Azure Government, so you can see the service spun up here. And what we're going to do is we're going to update the code, we're going to push the code change to our version control system, and we're going to run that through our build process and actually trigger the device update in the firmware updating scenario. So this is the code for the device itself, and if you're not a low-level C programming expert, just bear with it. We're just going to go ahead and make a couple integer changes here on the values, and we're going to change the speed of the motors themselves. Right now they're maxed out, forward and reverse speed at full speed ahead or full speed reverse. We're going to go ahead and slow this down. So we're going to change this to 50. Notice how I'm using Visual Studio Code. These are some of the great integrations that Microsoft has with IoT devices. There's a great extension for building for Arduinos and also a number of other embedded devices directly in the code editor. Notice here that I'm also using Git to manage my source control. I'm going to go ahead and say, all right, slowing this down. And we're going to, again, pretend that we're a contractor or in-house developer that's actually making the code change for the firmware update. So I'm going to go ahead and push this to my version control system. So where did that go? So in this case, I'm running a simple version control system. I'm using GitLab in this case. This could be GitHub, GitHub Enterprise, Visual Studio, Team Services, what have you. Again, the concepts are totally applicable. And what we've done is if I refresh this page, I've actually gone ahead and triggered a build. This entire build process, in fact, this GitLab instance runs entirely in containers, so it's completely portable and completely ephemeral, and it all runs on Docker, or rather Azure Government. So what we've gone ahead and done is we've triggered a build of our service, and let's take a look at that pipeline. So there are 3 stages to this pipeline. The build stage, which actually takes the code and compiles it. Let's go ahead and take a look at that. And the compilation, notice we're using Docker. We're running this entire build chain through Docker. We can define all of the build steps. So as a contractor, we're going to have some low-level dependencies. Maybe we're going to do some cross-compilation. In this case, we're just going to install the Arduino dependencies and build the image. So now we have a Docker image. We've packaged our code in a Docker image. So the next step is we're going to actually, we need to push this image somewhere. We need to stage it for release to the device itself. So what we're going to do is we're going to push this image to a registry. If you're not familiar with a container registry, this is considered your bag of Legos or all your building blocks for your containerized content. In many instances, folks that are familiar with containerized development are familiar with registries that consist of things like Java apps, Node apps, SQL Server, etc. In this case, we've just added an embedded app, an embedded system running C code. And the last step here is where we need to actually trigger the update on the device. Notice how it says it's manual. So going through quality assurance, all right, this is great, but I want to go through a couple checks to make sure that the build accomplished, it ran through all the unit tests, which is what we skipped out on here, and that we actually have staged our devices for an update. And in this case, we're going to run one update, but you could apply this concept to thousands of updates simultaneously. So before we trigger the update, let's talk about Azure IoT. Go ahead and minimize this. So what you can see here is I have catted out the logs for the Azure IoT update service. This is running on my edge device. This is that Udo board, or that x86 board I have here. This is the service that's going to monitor Azure IoT for any staged updates. And when I trigger the update, it's going to say, hey, twin property, start the update process. It's going to download the Docker image that we just built and pushed. It's going to start it. And then within the Docker container, again, we get security by default with these Docker containers. It's going to actually update the device through a terminal connection, which is what we have plugged in. So we'll see if this works. So let's go ahead, and go to our browser. Let's go back to the jobs view. And notice we're ready to go for a manual update. And we're going to go ahead and trigger that update and watch what happens. So again, this entire build process has run in containers. So it's going to trigger the image. It's going to launch it on the device. And you can see that it's now picked up the update state. So I'll go ahead and minimize this. So you can see now that it's downloading the latest image. Oh, and it failed. So let's go ahead and start it up again. And we will trigger that. We'll go ahead and retry this. We did disconnect and plug it back in earlier, so that might have done that. Any questions so far on the actual process? I'm sorry, what data sheet? The actual code? This code right here?
Do you have an architecture diagram?
Oh, no, I don't have a, yeah, actually, I'll show it here.
Andrew is like, if I have the code, who cares about the architecture diagram?
I got you. So this is the architecture today. This is what I meant to show beforehand. So you can see what it's supposed to do is when you trigger the update, it'll go ahead and trigger the property update on IoT Hub. So you can see that the data property state has been updated, and then that initializes the firmware update. It downloads the Docker image, and then it sends the code to the container. Any questions on this? This is actually Microsoft's recommended flow for executing firmware updates across devices. Oh. Any questions so far? Yeah, no. So we're paused there. So I'm running into an error. The Wi-Fi is causing some issues with the download. But.
So, I have a question.
Sure.
So you downloaded the Docker container to the edge.
Yep.
And then you connected your
Correct.
device to the edge.
Yep.
You plugged it in.
Yep.
And assuming your build was successful, you could have downloaded that
Correct.
update to the edge device.
Yep.
And then onto this.
Yep. Yeah, so I'm doing so I apologize, the network's being a little difficult, so I'm doing an internet sharing through to my edge device because I wasn't sure on the Wi-Fi. But what happens is it triggers the download, so you saw the download triggered on the edge device. It downloads the image and then runs that container and connects it, mounts the device port into the container and then uploads the actual engine.
In real world scenario, firmware updates can, in real world scenario,
Yep.
firmware updates can be provided
Oh.
via protocol, right?
Yeah, exactly. So in this case, I'm using a device that doesn't support more complex update strategies like firmware over-the-air updates. So if I had a supported Bluetooth chip that would support that, or other similar devices in the field, again, you wouldn't, dig up the device and then connect it back here. You'd actually send out a firmware over-the-air update.
Exactly.
The cool thing about the Azure IoT Twin properties is they can operate in very much a disconnected state. So for some reason that I lost internet from the actual trigger itself, and then I reconnected my edge device back up, it would resume the download process where it left off because it detects, all right, here's the last state of the update, and go forward and proceed.
So another question, follow-up question would be, how does cloud has intelligence to know the state of the device? For instance, if this device is not available at this moment, and you did a firmware update, and the device comes back up online, and now it should receive the update, firmware update.
That's correct. Yeah. So what you can do is you can have it, resume from the last left-off state and actually trigger the firmware update. The way that it's operating right now is because there's an internet connectivity problem. The container just actually dies out, so I don't have to worry about any stale content being left on my edge device, and that goes around to the security purview. So I'm actually glad it kind of died out or fizzled out there. So it just kills the container and restarts the service, or you can have it just kill it and remove it altogether. We haven't left any artifacts per se, whereas if you look at traditional updating scenarios, you're leaving behind artifacts. You have to install bloated OSs and complex architectures to support that.
Your question around firmware updates in the air. One of the interesting things, and Andrew's actually been working on this specifically, is around updates for certain devices through something as like digital radio, because of the ephemeral state and the small package capability of creating very ephemeral, very small update packages with Docker. You can actually have various means of updating things that are in field, right? So whether it's maybe I only have a digital radio connection, or maybe I have a ship at sea, and my Wi-Fi bandwidth is limited to a large degree. The ability to create very small container footprints, right? Minimal OS environments and small packages allows for much more diverse ways of updating devices, whether they be edge devices or sensors or what have you.
Yeah, and it looks like, so when I reinitiated the second round, it looks like that update went through, so you could see that it actually did just what I said, is it left off, it picked up the last known state of the update and went ahead and actually completed it. So you can see that it actually updated the sketch to the device. So if we turn it back on, it should move a little bit slower. So hopefully no one else has got the Bluetooth going here. So it did slow down. It did slow down a little bit. It's not as full power, but you get the gist. So.
That's because the battery drained.
Yeah, exactly. Any questions on that?